Hello everyone, today we are presenting Chain of Thoughtlessness, an analysis of CoT in planning, a NeurIPS 2024 paper. The main idea we explore is whether the chain of thought prompting actually improves reasoning in large language models, especially for planning tasks. On the left, we have the standard view held by the many AI communities, the belief that the chain of thought prompting unlocks latent reasoning capabilities. We tend to assume that by forcing the model to output the steps, we are enabling it to perform robust problem solving. However, the paper challenges this assumption with a research question: is the model actually planning and generating new solution based on the logic, or is it simply performing the pattern matching? Their hypothesis is that the model is not reasoning through the problems from scratch, but it is instead retrieving the similar patterns it has seen before in the training data to mimic a solution.
To study this question, the authors use the Blocksworld planning domain. The model is given an initial block arrangement and must produce a sequence of actions that achieves a goal state. Planning here has a binary ground truth. A plan is strictly correct or incorrect. This setup removes ambiguity and clearly reveals whether the model is reasoning or simply generating plausible sounding text. The authors then stress test chain of thoughtlessness prompts in two ways. First, by adding positive and negative constraints like stack A on B versus do not stack A on B. Second, by obfuscating names, changing block A to block X, ZY. A genuine reasoning system should handle these changes. A pattern matching system breaks when the surface form shifts. This helps distinguish reasoning from memorize patterns.
Here, the results show that these models are extremely brittle. They only perform well in a very narrow Goldilocks zone, where the test problem looks almost exactly like the example prompts they were trained on. But the moment the problem becomes even slightly longer or a bit different in structure, the performance crashes, and it drops below 20%. And this tells us that the chain of thought doesn't really generalize, even to planning tasks that are only a little bit harder. The model struggles more and more as the required reasoning steps get longer, which is what we call the length bias. And the clearest evidence that the model isn't actually reasoning is that even small changes like renaming the blocks or completely breaking it, that tells us the model isn't understanding the logic behind the task, it's just imitating the surface structure of the examples it has seen. So even when the model produces a plan that looks correct, it often contains actions that are invalid. In other words, the chain of thought is improving how the reasoning appears, not the actual reasoning capability underneath. And what really shows is that the model is behaving more like an approximate retrieval system. It's matching patterns that are similar rather than functioning as a true reasoning engine. And these findings have a big implications for the future AI planning. What we are seeing is that the large language models simply aren't stable or reliable enough to be used as standalone planners. They are too fragile, and small changes can cause their reasoning to fall apart. A better approach is to use them differently, not as the ones creating the full plan, but as the translators. In this hybrid setup, the LLM converts natural language in a structured planning problem, and then symbolic solvers can verify and generate the actual reliable plans. This way, we get the best out of the two worlds: the flexibility and expressiveness of the language models, combined with the correctness and the reliability of symbolic system. And this is all we have. Thank you for listening.